Welcome to another exciting demo of the Semantic Annotation System for Graphic User Interfaces. Hi, I'm Professor Doug Lyon, and I'm here to demonstrate for you a mechanism for automatically creating graphic user interfaces using reflection and annotation. In this particular demo, we're going to show you how to build an operator for an image processor which works by creating an implementation of an image processor interface. The input will be an image and the output will be an image, but no graphic user interface will be constructed by hand. All GUIs are constructed automatically and on the fly. Here's a fisheye processor. The business logic is represented by the code in the process interface implementation. Here the image comes in and the image goes out. That's the basic input and output relationship for image processing. But what about the graphic user interface? Typically people put graphic user interface semantics directly into the graphic user interface, but this is mixing business logic with GUI logic. We prefer a different approach. In this approach, semantic annotation allows us to define a range on a variable. This allows us to construct an interface that's entirely consistent with the use of that variable. For example, here's something called gamma, which takes as its input a float. And here is a programmatic description of the minimum, the maximum, the semantic representation of the name, gamma, the increment, which is used to number the model, or model the number, and here is a default value. All of these things are added in an automatic fashion to a menu system. The menu will allow us to select the float operator, and then it will allow us to execute it automatically. It constructs the graphic user interface in a completely automatic fashion, and it executes it also in an automatic fashion. Here's another example called the fast processor. In this case, we're using ints. Ints on input involving the width, and ints on input involving the height. These ints are typical of the kinds of parameters that are used to govern the operation of image processing programs. What we'll do now is give you a practical demonstration. We'll open up an image. Here is a little airplane stored as a JPEG. And now what we'll do is we'll go into our image processor operators, and we'll select an operator which allows us to do the image processing. We can either set the parameters without having any effect, or we can execute the new parameters in real time. Each time the slider arrives at a new variable, the operator is fundamentally changed, and those parameters allow us to impact directly the image as we see it. Here's another example. In this one, what we have is a mechanism called the feedback processor. The feedback processor allows us to alter many parameters: the center for the X and Y location of the operation, its angle, and a continuous update mechanism. If we increase the number of iterations and increase the distance away, we can now see that there are substantial ramifications for altering numbers by small amounts. These operators are built in a completely automatic fashion without any graphic user interface code, and enable us to quickly prototype our business logic and even deploy it if we're happy with the interface as it stands. In the case where we want customized or new interfaces, these can easily replace the automatically constructed interface, thus improving throughput for testing and allowing us to bifurcate the team's roles. One role of the team will be in creating the business logic for the graphic user interface, and the other role for the team will be in the creation of custom graphic user interfaces. The GUI team may have nothing to do with how the business done by creating custom GUIs. So in this way, they can create the GUIs in a fairly automatic fashion, test their business logic, and move on to the next operator. Thank you for your attention.